Right, this is Unit 9, Lesson 1, Parabolas. Our lesson essential question is, what are the geometric properties of a parabola and how do they relate to algebraic representations of a parabola? At the end of this lesson, you'll be able to understand and apply the geometric properties of parabola. Concept, conic sections. A conic section is a curve formed by the intersection of a plane and a double right cone. So for example, basically if I slid a piece of paper into something like this, you're going to get 4 different shapes usually. So you can either get a parabola, which of course is that U shape, a circle, which we all know what a circle is, an ellipse, which is like it's almost like an oval, but there are specific requirements for an ellipse, and then I have hyperbola. So parabola, the intersecting plane cuts through one side of one cone. A circle, the intersecting plane is perpendicular to the x-axis. An ellipse, the intersecting plane cuts through both sides of a cone. And a hyperbola, the intersecting plane cuts through both cones. Each conic section has a geometric definition that describes a property of every point on the curve. The conic sections covered in this topic can be graphed in a coordinate plane and can be represented by a second-degree equation in 2 variables. The general form of a second-degree equation is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. It's a lot of letters. All the conic sections covered in this topic will have equations where the coefficient of the xy term is 0. A non-zero xy term results in conics with an axis of symmetry that is neither horizontal nor vertical. Example 1, derive an equation of a parabola. How do you write an equation of a parabola? What is an equation for the parabola with focus 0, 2 and directrix y equals -2? Use the definition of parabola to write and simplify the equation. A parabola is the set of all points in a plane equidistant from a given point, called the focus of a parabola, and given line called the directrix. For this parabola, the focus f is 0, 2. The directrix is y equals -2. A point P on the parabola is xy, and the closest point Q on the directrix is x, -2. Okay, so the focus is 0, 2. Here's my point. So it's 4, 4. By the definition of a parabola, the distance from P to F must equal the distance from P to Q. So I take the square root of x minus 0 squared plus y minus 2 squared. Okay, so again, I pull these right here. So here's x minus 2, that's y equals -2, and then the 0, 2 is the point that I was given. So x was 0, y was -2. There. Equals the square root of x minus x squared plus y plus 2 squared. X squared plus y minus 2 squared equals y plus 2 squared, because this equals 0. X squared plus y squared minus 4y plus 4 equals y squared plus 4y plus 4. X squared equals 8y. Divide both sides by 8, I get 1/2 x squared equals y. So the equation for the parabola with focus 0, 2 and directrix y equals -2 is y equals 1/8 x squared. How do you write an equation of a parabola? What is an equation for the parabola with focus 4, 0 and directrix x equals -4? So by sketching the parabola based on the given information, you can see that this parabola opens to the right. So here's my directrix line. Okay, here's my parabola. 4, 0 is my focus. As with the previous example, you use the distance formula to set PF equal to PD. So here's P, here's a point. D is -4y. My focus is 4, 0. So I get square root of x minus 4 squared plus y minus 0 squared equals the square root of x plus 4 squared plus y minus y squared. When I solve that, I get x minus 4 squared plus y squared equals x plus 4 squared. So x squared minus 8x plus 16 plus y squared equals x squared plus 8x plus 16. This simplifies to y squared equals 16x. And so x equals 1/16 y squared. Equation for a parabola with focus 4, 0 and directrix x equals -4 is x equals 1/16 y squared. All right, let's try it. What is an equation for the parabola with the given focus and directrix? So basically, I'm coming up with these 3 points, my focus point, my directrix point, and then the point x, y. I'm going to use the distance formula to solve for my equation. So my first point, my focus is 0, -3. My directrix is going to be, it's y equals 3. So I have x, 3. And then my other point is x, y. Okay. So now I'm going to take the distance formula, which of course is taking 2 points, subtracting them, plus the y coordinates of 2 points. So I'm going to take the point for my first one and the focus, and I'm going to set that equal to the point and the directrix, okay? So I'm going to take my point, which is x minus 0 squared, plus my y values, y minus, and it's minus -3, so that becomes a plus 3 squared. That's going to equal the square root of x. So I'm going to go back to my point, and then my directrix minus x squared, plus my y value for my point, and then the y value for my directrix is minus 3 squared. Now when I solve this, I get the square root x minus 0 is just x, so I get x squared plus y plus 3 squared. Don't bother trying to simplify it yet. X minus x is 0, and then so I just have y minus 3 squared. So what you're actually going to do, both of these are under square roots. So in order to get rid of square roots, I want to square everything. So that gives me x squared plus y plus 3 squared. And really all that's doing is just getting rid of this square roots. That's it. That's all it did. Okay. Now I'm going to go ahead and factor everything out. So I get x squared, y plus 3 squared becomes y squared plus 6y plus 9, and that equals y minus 3 squared becomes y squared minus 6x plus 9. I'm going to move all my x values to one side, all my y values to the other side. So that gives me, oh, that's supposed to be y, not an x. There we go. Okay, so I have x squared equals y squared minus y squared minus 6y minus 6y plus 9 minus 9. So that means x squared equals negative 12y. I'm going to solve for y, so divide both sides by negative 12. So I get x squared divided by x squared divided by negative 12 equals y. So y equals negative 1/12 x squared. Okay. That's the line, or that's my equation for my parabola. Okay. For B, I have a focus of negative 2, 0, directrix of x equals 2. Notice the x versus the y up here, so that's going to change my first. So notice here I did my directrix x 3. So my directrix for x equals 2 is going to be 2y, okay? So that means my focus is negative 2, 0. Directrix is 2, 0. And my point is x, y. Again, I'm going to use the distance formula. So I have x, negative 2 becomes plus 2 squared plus y minus 0 squared equals the square root of x minus 2 squared, and this is supposed to be y, not 0, plus y minus y. Oops. Sorry. Okay. So what that means is I have the square root of x plus 2 squared plus y squared equals the square root of x minus 2 squared. Again, I square both sides. That gives me x plus 2 squared plus y squared equals x minus 2. Ooh, What just happened? No idea what just happened. Okay. Minus 2 squared. That's great. So when I factor this out, I get x squared plus 4x plus 4 plus y squared equals x squared minus 4x plus 4. So that gives me, when I simplify, I get y squared equals negative 8x. I solve for x, so x equals negative 1/8 y squared. All right, example 2, relate the focal length of a parabola to its equation. How does the distance between the focus and vertex affect the shape of a parabola? So the focal length of a parabola, the absolute value of c, is the distance between the focus and the vertex measured along the axis of symmetry. So here's my focus, vertex, axis of symmetry. For parabolas that open upward or to the right, c is greater than 0. For parabolas that open downward or to the left, c is less than 0. Drag the point to increase the focal length from 2 to 4 to 6. So here's 2 to 4. Notice my directrix is moving as well to 6. So if my focus is at 6, my directrix is at negative 6. Notice that the graph of the parabola becomes more vertically compressed. If I drag the point to negative 2, so right here, they're the exact same. I drag it to negative 2. Notice my parabola is now opening downward, and my directrix is positive. Okay, so this actually can tell me if it opens upward or downward. If my focus has a negative x, or it has a negative y value, then I'm opening downwards. Okay. E, how does the focal length relate to the equation of a vertical parabola? Consider a parabola that opens upward with vertex at the origin, focal length c, and containing the point P, x, y. Okay, so here's my vertex at the origin. Here's c, my length between my directrix and my vertex on my focus. Here's point P, and then that point also corresponds to my directrix. Based on the definition of a parabola, point P, x, y must be equidistant from the focus and the directrix, which means I can set them equal to each other. Okay? So when I do that, here's my focus point 0, c, my point x, y, and my directrix x, negative c. Okay? So I set up my equation, x minus 0 squared plus y minus c squared equals the square root of x minus x squared plus y minus c squared. So x squared plus y minus c squared equals y minus c squared. When I factor all that out, I get x squared plus y squared minus 2cy plus c squared equals y squared plus 2cy plus c squared. When I simplified just to get x squared by x on one side and y on the other, I get x squared equals 4cy. I solve for y, I get 1 over 4c x squared equals y. So the equation for a vertical parabola with vertex at the origin with focal length c is y equals 1 over 4c x squared. Using this equation, you can see how the focal length affects the value of a in the equation y equals ax squared. All right, so let's try it. A parabola has a focus of 4, 0, and a directrix at x equals negative 4. So between 4 and 0, if I add these two numbers together, so 4 plus 4 is 8, divided by 2 is 4, so it's going to be right at 0. So the vertex of the parabola is at 0, 0. Is the equation in the form y equals ax squared or x equals ay squared? Okay, so we can tell this based off of where the So the directrix is at x equals -4. So that means I'm looking at x equals ay squared. And then what is the focal length? So the focal length is going to be looking at this is -4. That means it's 4 and it's 4 away from 0. So it's 4. It's my focal length. And then what is the equation of the parabola? So again, I have my points. So P is x comma y. My focus is 4, 0. And then my directrix is -4y. So square root of x minus 4 squared. Oh my goodness. There we go. Plus y minus 0 squared equals the square root of x plus 4 squared plus y minus y squared. So that gives me x minus 4 squared plus y squared equals x plus 4 squared. Okay. So that gives me x squared minus 8x plus 16 plus y squared equals x squared plus 8x plus 16. So when I solve, I get y squared equals 16x. So when I solve for x, I get x equals 1/16 y squared. All right, example 3, write an equation of a parabola. What is the equation of the parabola? A parabola with vertex 0, 0 and focus 0, -0.5. So start by sketching the parabola based on the information you're given. So I know I have a 0, 0 parabola. Here's my vertex. And the focus is 0, -0.5, which means my focus is down here, which means my parabola is going to open downwards. Looking at the graph, you see that the parabola has a vertical axis of symmetry, so its equation has the form y equals ax squared. The coordinates of the focus are 0, -1/2. So c equals -1/2. I substitute that into the equation. Y equals 1/4cx squared. When I do that, 4 times -1/2 is -2. So I get -1/2 x squared. So this parabola with the equation y equals -1/2 x squared. You can, of course, also determine what the directrix is. In this case, the directrix would be y equals 0.5 and solve it that way too. Parabola with vertex 0, 0 and directrix x equals 5. I start by sketching the parabola based on the information I'm given. So x equals 5 is a vertical line as opposed to a horizontal line, where y equals is a horizontal. So this is vertical, which means my graph's either going to open to the left or to the right. In this case, my directrix is positive, which tells me my graph opens away from that. So it's going to open towards the left side of the graph. So to write an equation for the parabola, first determine the focus. The vertex is equidistant between the directrix and the focus. So if the vertex is at the origin and the directrix is at x equals 5, the focus must be at -5, 0. So then c equals -5. The parabola has a horizontal axis of symmetry. So use the equation x equals 1/4cy squared, where c equals -5. So this gives me -1/20 y squared. So that's what the equation is. Let's try it. What is the equation of a parabola with focus 0, 6 and directrix y equals -6? So again, this is a y equals -6. This tells me the directrix is down here, which means my focus point is 0, 6, so it opens upwards. So this gives me, that means my vertex is 0, 0. So again, I can do exactly what I've been doing, or I can use that equation. So this is a y equals -6. which means I'm looking at y equals ax squared, okay, which is really y equals 1 over 4cx squared. So my focus is 6, so that's what c is. C equals 6. So I can just solve. Y equals 1 over 4 6 x squared. So that gives me y equals 1/24 x squared. For B, what is the equation of the parabola with focus 1/5, 0, and vertex 0, 0? Okay, so this gives me a focus of 1/5. So my x value is 1/5, and then my vertex is 0, 0. So this tells me x equals 1/5 is my directrix. X equals negative 1/5 is the directrix. Okay, so this is going to open to the right. This is a parabola that goes like this, and it opens to the right. Okay, so that means my formula is x equals 1 over 4c y squared. Okay. So this is my c value. Is 1/5. So x equals 1 over 4 times 1/5 y squared. This gives me 1 over 4/5 y squared, which equals x equals 4/4 y squared. At example 4, use a parabola to model a real-world situation. One type of solar cooker is a reflective parabolic dish. Okay, so this parabolic dish here. Its cross-section is a parabola modeled by the equation y equals 1 over 108x squared. The distance is measured in inches. The bracket that holds the pan for the cooker needs to be placed at the focus. Assuming that the vertex of the parabolic dish is at the point 0, 0, at what coordinates should the bracket be placed? So here's my vertex, 0, 0. Here's my focus, 0, c. And my parabolic equation is y equals 1 over 108x squared. So distance. Formulate the distance from the focus to the vertex is the focal length c. The given equation is the form y equals 1 over 4c x squared. So 1 over 108 equals 1 over 4c, and I need to solve for c. So c equals 27. In this example, the focal length is 27. The vertex is at 0, 0, so the focus is at 0, 27. The bracket should be placed 27 inches from the vertex. All right, let's try it. If the dish in this example has a depth of 30 inches, what is the diameter of the cooker? So basically what we're doing is we're going to take this 30 inches, that's how deep it is, we know that, and substitute in that value for A. So right now what I have is y equals x squared over 4a. Okay? X is the radius, so we want to keep that in mind. A is our depth, okay, and we're solving, and we know y is our focal length, which was 27, which was c. Okay, so remember that c equals x squared. Okay, so from here, c we know is 27 equals x squared. We don't know what that is. 4 times a, which is 30. Okay, so this gives me 27 equals x squared over, okay, so 27 equals x squared divided by 120. I multiply both sides by 120, which gives me 3,240 equals x squared. I'm going to take the square root of both sides. Okay. This gives me 56.9 approximately equal to x, but remember x is the radius, so I need to multiply by 2. So when I do that, 2 times 56.9 gives me approximately 113.8 inches. All right, example 5. Complete the square to find the focus and directrix. The equation for a parabola is given by 0 equals y squared minus 8y plus x plus 14. What is the equation in vertex form? Use the vertex form to identify the vertex, focus, and directrix. The vertex form of a vertical parabola is y equals a times x minus h squared plus k, and the vertex form of a horizontal parabola is x equals a times y minus h squared plus k. Notice that h is always associated with x and that k is always associated with y. Write the equation in vertex form by completing the square. So 0 equals y squared minus 8y plus x plus 14 is in standard form. I isolate the quadratic expression, negative x minus 14 equals y squared minus 8y. I complete the square, so negative x minus 14 plus 16, y squared minus 8y plus 16, which gives me a factor of y minus 4 squared, and then 2 minus x. So x equals negative 1, y minus 4 squared plus 2. I just made sure x was positive. I solved for x. So the vertex HK, where h equals 2 and k equals 4. Use the value for a to find the focal length. In this equation, a equals negative 1. In previous examples, you have seen that a equals 1 over 4c. So negative 1 equals 1 over 4c, which c equals negative 1/4. The equation indicates that the parabola is horizontal and opens left or right. In this example, c is negative, so the parabola opens to the left. The vertex is 2, 4, so the focus is 2 minus 0.254, or 1.754. The directrix is the same distance to the right of the vertex, so the equation is x equals 2.25. You can graph the parabola to confirm that the vertex, focus, and directrix you found make sense. All right, let's try it. Use the vertex form to identify the vertex, focus, and directrix of the parabola with each equation. So 0 equals negative y plus 2x squared minus 4x plus 6. Okay, so this is in standard form. I want to isolate the quadratic. So I have y equals 2x squared minus 4x plus 6. Factor 2. This is y minus, divide both by 2, so that's 1/2 y minus 3 equals x squared minus 2x plus 1. X squared minus 2x plus 1. So that is 1/2 y minus 2 equals x minus 1 squared. Solve for y. So that is y equals 2x minus 1 squared minus 4. Okay, so my vertex is 1, 4. So my vertex is 1, 4. Okay, and then focus in the directrix. So vertex A equals 2 in this case. So remember A equals 1, 4c. So this is 2 equals 1 over 4c, which is, I will solve for c. So when I do that, I get 8c equals 1. So c equals 1/8. Okay. So the vertex was 1, 4. So the focus is 1 minus 1/8, 4, which is 1 and 4 minus 1/8. Which will give me 1 and 33/8. And then the directrix, y equals 33/8. Okay, for b, 0 equals x squared plus 6x plus 4y plus 5. So again, I want to solve 6x plus 4y plus 5. So I want to solve for the quadratic. So I can negative 4y minus 5 equals x squared plus 6x. 9 to both sides to complete the square. So negative 4y minus 5 plus 9 equals 6x squared plus 6x plus 9. It's negative 4y plus 4 equals x plus 3 squared. Solve for y. So I get y equals 1/4 squared. Okay, so that means my vertex is 3, negative 3, 1. Minus 4, this will be plus 1. Again. Okay, and then I'm solving for my focus. So again, my focus A equals negative 1/4. Remember, A equals 1/4c. So negative 1/4 equals 1/4c. C. So this gives me 4c. 4c equals 4c. Okay, so c equals negative 1. And then since the vertex is negative 3, 1, to be negative 3 minus 1, which is negative 3, 0. And that's my focus. Okay. And then my directrix is going to be y equals 2. So negative 3. So 1 plus 1 gives me 2. Concept summary, parabolas. Definition, a parabola is the set of points on a plane that are equidistant from a given point, the focus, and the given line, the directrix. Graphs, the parabolas below have vertex 0, 0. Parabolas can also be translated anywhere in the coordinate plane. So in this case, my vertical axis of symmetry x equals 0, my focus is 0, c, my directrix is y equals negative c. For my horizontal, axis of symmetry y equals 0, focus is c, 0, and the directrix is x equals negative c. Equations for a parabola with vertex at the origin and the focal length of the absolute value of c, y equals 1/4c x squared, and x equals 1/4c y squared. And that is the end of Unit 9, Lesson 1.